Hello everyone, this is Nagaraju Rebba. So today I am going to discuss matter around us. So before I am going to discuss these matter around us, you know that by the observation of in our surroundings, we are observing the different types of materials. In that all materials are contains some different physical and chemical properties, and at the same time, so by the observation of these materials, that all materials are nothing but different types of melting points and boiling points. So see here I am saying that first, so what is the states of a matter? What is the states of a matter? See here I am saying the states of a matter. You know that in our previous classes and at the same time we have some knowledge is there. So what is that knowledge means? You know that by the observation of any material, so that material compulsory contains three important points. So one is called as solids, and the second one is called as liquids, and the third one is called as gases. So first one is called as liquids, and the second one is called as first one is called as solids, second one is called as liquids, and the third one is called as gases. Means in our surrounding we are observing that so many materials are there. In that all materials are contains the different physical forms. At the same time, that the different physical forms we are saying as a states of a matter. You know that I will say one example. So suppose you know that in our daily life we are saying water molecule. So this is called as a formula of the water molecule. Formula of the water molecule. So these water molecule will show so three different physical states. This water molecule will show the three different physical states. So this water molecule is present in the solid state. That solid state we are calling as a ice. If the water molecule is present on the solid state, if the water molecule is present on the solid state, so that solid state we are calling as a just like ice. If the water molecule is present on the liquid state, if the water molecule is present in the liquid state, you know that liquid means it is nothing but a water molecule, and at the same time, when the water molecule is present on the gaseous state, so gaseous state means it is nothing but a water vapor. Gaseous state means it is nothing but a water vapor. So like that, by the observation of different materials, what I am saying that here, so first I am saying the states of a matter. You know that, so the matter is contains the different forms, but here you will see, what I am saying that if you see by the observation of a water molecule, so the water molecule contains the three important physical states, so that is called as a solids, liquids and gases. So by the observation of the water molecule, so what is the solid form of the water molecule means ice, and what is the liquid form of the water molecule means liquid only, and what is the gaseous form of the water molecule means it is nothing but a vapor. It is nothing but a hot vapor or vapor. So therefore these three are the three different physical forms of the water molecule. And at the same time, by the observation of in our surrounding materials, so just like so which materials are follows like these three physical states means suppose you will see by the observation of the by the observation of the solid materials like here the solid materials means suppose if you see so wood and a coal. So wood and coal both are the called as a solid materials. Wood and coal both are the present as a solid materials, and at the same time by the observation of your petrol. By the observation of a petrol, so this petrol is present on the liquid in the state. Petrol is present on the liquid in the state. See here. So by the comparison of the water molecule, how the water molecule is showing as a three physical states like solids, liquids and gases, and at the same time here by the observation of a wood and coal materials. Observation of a wood and coal materials. These wood and coal materials both are present in the solid form, and at the same time you know that so another form of the wood coal is called as a petrol. So generally that petrol is present in the liquid form. Generally that petrol is present on the liquid form, and at the same time you will observe that so one more thing that is called as a milk. So the milk is also called as a liquid. The milk is also called as a liquid, but when compared with the properties of petrol and milk are completely different. So if you observe the milk and petrol, so milk, petrol both are called as the liquids by the observation of a physical properties and chemical properties. So these both are the contains the different physical and chemical properties. These both are the contains the different physical and chemical properties. Now you can see I am going to explain matter. Now I am going to explain that is called as a matter. See, first I am saying the definition of the matter. Definition of the matter. See here, definition of the matter means See here, I written a board just like see. This is called as the definition of the matter. Anything which has a mass. Anything which has mass. See here, anything which has mass and occupies the space is called as a matter. Anything which has mass and occupies the space is called as a matter. You know that in our surroundings we are observing that so many materials are there. In that all materials are compulsory contains just like mass and as well as that materials are occupies the space is called as a matter. So anything which has mass and occupies the space, anything which has the mass and occupies the space is called as a matter. You know that what I am saying that in our surroundings we are observing the different materials are there. In that all materials are compulsory contains mass as well as that materials are occupies the space is called as a matter. So what I am saying that suppose this is called as the chalk piece. So these chalk piece contain the some weight. Suppose you will see here I am writing that this one is called as the chalk piece. In this chalk piece contains the some weight. Like this is called as the weight of the chalk piece. And at the same time these chalk piece contains some this chalk piece is occupies like this is called as a volume. So means here this chalk piece contains both mass means weight and as well as it will occupy the space in our nature. Suppose this is nothing but occupation of a chalk piece. This is nothing but occupation of a chalk piece. So that's why simply we are saying this is also called as one of the matter. And at the same time by the observation of a duster, by the observation of a just like a book, by the observation of a pen, by the observation of in our shirt, by the observation of in our bag, in our water bottle, in our TV, just like by the observation of this blackboard and by the observation of this classroom and a fan and a bicycle and in our motorbike, in our car, in our bus, whatever it. So by the observation of all these examples, they are all the examples of the matter. Why? Because what examples I am saying that all materials are contains the mass as well as that materials are contains that materials are occupies some space in our nature, and at the same time yourself and ourselves also one of the matter. Why? Because we are contains the some amount of the weight, and at the same time we will occupy the some space. We will occupy the some space. So that's why that is called as a matter. So what I am saying that here anything which has the mass in our surrounding, if you observe any material, that material contains a particular weight, and at the same time that material occupies a particular space. Particular space in our nature. So therefore that materials are called as examples of the matter. Means that's why I am using this word that is called as anything. So anything means in our surrounding. In our surrounding any material is there, that all materials are contains the weight, and at the same time that all materials are occupies the space. That's why I am saying that anything which has a mass and occupies the space is called as a matter. Anything which has mass and occupies the space is called as a matter. So generally these matter are mainly classified into the two types. Generally these matter are mainly classified into the two types. See here I am saying that so classification of a matter. Here you will see these matters are mainly classified into the two types. Here one is called as a physical classification. And the second one is called as a chemical classification. So generally what I am saying that these matters are mainly classified into the two types. So one is called as a physical classification and the second one is called as a chemical classification. See here I am saying that so what is the physical classification? Here you will see I am writing that the physical classification of a matter. So the first one is called as a solid materials. The first one is called as a solid and the second one is called as a liquids. And the third one is called as a here gases. And the fourth one is called as here plasma. And the fifth one is called as right here Bose-Einstein condensation. Bose-Einstein condensation. Bose-Einstein Bose-Einstein condensation. See here. So the matters are mainly classified into the two types. One is called as the physical classification, and the second one is called as the chemical classification. In this physical classification, again classified into the five types. Here the first one is called as the solid materials, and the second one is called as the liquid matter, and the third one is called as the gaseous state. And what is the fourth state of a matter means that is called as the plasma state. And what is the fifth state of a matter means that is called as the Bose-Einstein condensation. Bose-Einstein condensation. And at the same time here you will see these chemical classification is also again classified into the two types. One is called as here the pure substance. One is called as the pure substances. Pure substances. And the second one is called as here mixtures. The second one is called as here mixtures. One is called as pure substances, and here the second one is called as mixtures. And again these pure substances are classified into the two types. One is called as elements. One is called as elements, and the second one is called as compounds. Elements, and the second one is called as compounds. And here also these mixtures also again classified into the two types. One is called as homogeneous mixtures, and the second one is called as heterogeneous mixtures. See here, this is called as a clear picture of a matter. Clear picture of a matter. Once again I am saying that. So generally these matters are mainly classified into the two types. One is called as a physical classification, and the second one is called as a chemical classification. Here by the observation of the physical classification, first one is called as a solids, and the second one is called as the liquids, and the third one is called as the gases, and the fourth state of a matter is called as a plasma. Fourth state of a matter is called as a plasma, and the fifth state of a matter is called as a Bose-Einstein condensation. Bose-Einstein condensation. And the next one is called as the chemical classification. By the observation of the chemical classification, these chemical classification is mainly classified into the two types. One is called as the pure substances, and the second one is called as the mixtures. Here the pure substances are again classified into the two types. One is called as the elements, and the second one is called as the compounds. And by the observation of these mixtures also mainly classified into the two types. One is called as a homogeneous mixtures, and the second one is called as a heterogeneous mixtures. Homogeneous mixtures and heterogeneous mixtures. So now you will see here I am saying that what is the importance of the physical classification. What is the importance of the physical classification? So these the physical classification is very important because of in the next we are going to discuss only solids, liquids and gases behaviors. So first you will see what is the solid. Here you will see, you know that in our surroundings so many solid materials are there. They are all under the examples of the solid materials only. Like a chalk piece, like in our shirt, in our human body, blackboard, like in our classroom, in our bag, in our pencil, whatever it in our pen, they are all under the examples of the solid materials only. And at the same time here you will see liquids. So generally liquids means you know that water molecule and milk particles and oil particles. So like a petrol, like these are all the examples of the liquid materials. So what I am saying that liquids means water molecule, petrol, kerosene, like here the petrol, kerosene and the milk, like oil, they are all the examples of the liquid materials. And coming to the gaseous materials, you know that gases means nitrogen gas, oxygen gas, next helium gas, chlorine gas, bromine gas, whatever it you will take a carbon dioxide gas, carbon monoxide gas, hydrogen gas, like these are all the examples of the gaseous materials. These are all the examples of the gaseous materials. And the next one is called as the fourth state of a matter. Fourth state of a matter, that is called as a plasma. So plasma means it is nothing but an ionized gas. Plasma means it is nothing but an ionized gas. Ionized means it is nothing but a vaporization of a gas. Suppose here in the plasma state, just like ions and molecules, ions and atoms are contains coexist with each other. Ions and atoms both are coexist with each other. So therefore, simply you keep in your mind, plasma means it is nothing but an ionized gas. Plasma means it is nothing but a ionized gas. And the next one is called as the Bose-Einstein condensation. Bose-Einstein condensation. So Bose-Einstein condensation is nothing but a superfluid phase. Bose-Einstein condensation is nothing but a superfluid phase. Superfluid phase means here you will see the word condensation is very important. So condensation means like vapor molecules are condensed, right? Vapor molecules are converting into a liquid molecules. Vapor molecules are converting into a liquid molecules. So therefore that process is called as a condensation. Vapor molecules are converting into a liquid molecules. Therefore that procedure is called as a condensation. Here what I am saying that Bose-Einstein condensation. So the Bose-Einstein condensation is nothing but a superfluid phase. Superfluid means it is nothing but a liquid. So the Bose-Einstein condensation is called as a superfluid phase, and at the same time that superfluid phase contains the very lesser temperatures. That superfluid phase contains the very lesser temperatures. This is called as in our physical classification of a matter. Physical classification of a matter. Now you can see I am explaining the properties of the solids and liquids and gases. Now I am going to discuss the properties of the solids, liquids and gases. So first I am going to discuss solid materials. So what are the properties of the solids? Here I am saying that step by step here you will see. Here generally solids contains solids have fixed shape. Solids have fixed shape. And the second point, solids contains solids have mass and fixed mass and volume. And here I am writing that so solids contains intermolecular distance are short. So solids contains intermolecular distance are short, and solids contains intermolecular force are strong. See here, I am saying that here first point, solid has a fixed shape. The solid materials are contains the fixed shape. Suppose you will see, so this is called as a pen. You can understand this one is called as a pen. So this pen contains a fixed shape. This pen contains the fixed shape, and it will contain the fixed amount of a volume, and at the same time it will contain the fixed mass. So this is called as a pen. What I am saying that this is the one of the example of based on the solid materials. So these pen contains the some particular shape. So the pen contains the some particular shape. Like this is called as a chalk piece. So this one is called as a chalk piece. So these the chalk piece also contains the particular shape. And a particular shape means a fixed shape. So this one is called as a shape of the chalk piece. And like if you observe, and this one is called as a what is that duster. So these the duster also contains some fixed shape. And by the observation of a book, so the book also contains some fixed shape. So that's why what I am saying that solids have the fixed shape. If you take any solid material, if you observe any solid material, that solid material contains the fixed shape. That solid material contains the fixed shape and a fixed volume and a fixed mass. So the shape of the molecule is fixed, and the volume of the molecule is fixed, and the mass of the volume and the mass of the molecule also fixed. That's why you keep in your mind, if you are seeing any material, any solid material, that solid material contains the particular means a fixed shape and a fixed volume and fixed mass. So that is called as a very important. So when you compare with the solid materials and liquid materials and gaseous materials, so first you will have the one idea. The solid materials are contains the fixed shape and a fixed volume and the fixed mass. Why? Because by the observation of the different materials, so that all different materials are contains the different particular shapes. So suppose what I am saying that here I am saying I am explaining the one example. So this one is called as a pen. So that pen contains the some particular shape, and the pen contains the some particular volume, and at the same time the pen contains the some particular mass. and at the same time by the observation of a textbook. So this one is called as a book. By the observation of this book, so the shape of the book is like this is called as a fixed shape. The shape of the book is called as a fixed shape, and at the same time volume of a book also fixed volume, and the mass of the book also fixed mass. So therefore, by the observation of simply in our observations, if you observe any material, that material contains the fixed shape and fixed mass and fixed volume. So that is a very important point. And coming to the next one, solids contains intermolecular distance are very short. Solid materials are contains the intermolecular distance are very short. Suppose you will see this is called as a solid material. In that solid material, the molecules intermolecular distance. The molecules intermolecular distance is a very short. Means here the particles are contains a very short in this compound. Suppose this one is called as a salt, NaCl. Salt means NaCl. By the writing of the NaCl, the NaCl is also called as one of the material, solid material. By the observation of the NaCl solid material, here this one is contains Na plus and Cl minus. Here this one is called as a positive ion, and this one is called as a negative ion. Here the positive ion, negative ion, positive ion and the negative ion, and here the positive ion, negative ion, positive, negative and a positive, and here also positive, negative, positive and a negative. Here the positive, like here negative, positive, and here negative, positive and a negative, and here also positive, negative, and here also positive, negative and a positive. By the observation of these solid crystal, by the observation of this NaCl molecule, here what I am saying that the intermolecular distance between the solid materials are very less, means very short. Here you will see the distance between these two molecules, these two sodium Na plus and Cl minus ions. These two Na plus and sodium ions are very close. That's why what I am saying that solids contains the intermolecular distance are very short. The solid materials are contains the intermolecular distance are very short. So that's why the solid materials are contains the more attractive force. The solid materials are contains the more attractive force. Why? Because the molecule to molecule, the distance is very short. By the distance is very short means the molecules are very close to each other. By the very close to each other means it is nothing but it will contain the more attractive force. That ions, that molecules are contains the more attractive force. That is called as a solids contains intermolecular distance are short. And next one is called as a solids contains intermolecular force are strong. The solids are contains the intermolecular distance are strong. Why? Because that all molecules which are participating on the solid material, they are all very close to each other. So that's why they are all contains the more attractive force. They are all contains the more attractive force. And at the same time, what I am saying that generally solid materials are solid materials are rigid structure. Rigid structure, very important. So rigid means it is nothing but a fixed. Rigid means it is nothing but a fixed. Suppose if you drop any material, like I will drop the one book on the floor. So what will happen means that book is present on the floor only. That book does not move in that place to another place because of it is nothing but one of the rigid structure. Rigid means it is nothing but a fixed shape. Rigid means it is nothing but a fixed structure. So that's why that solid material does not move on one place to another place when you drop on the floor. When you drop on the solid material, so that solid material is present on that particular place only, but that molecule does not move on one place to another place. So therefore that is called as a rigid. Rigid means it is nothing but a fixed. Rigid means it is nothing but there is no movement of that particular molecule. So therefore this one is called as a rigid. And what I am saying that generally solid materials are contains the more attractive force. Generally solid materials are contains the more attractive force. So due to that more attractive force, we cannot break that solid materials. Due to that more attractive force, we cannot break that solid materials. And at the same time, generally solid materials are contains the higher melting and boiling points. Generally solid materials are contains the higher melting and boiling points. And at the same time, so generally these solid materials are contains the densities, a particular densities. And at the same time, what I am saying that here, solid materials are just like one of the fixed shapes under one of the particular, yes, what is that volume. So therefore, this is called as information regarding the, yes, solid materials. Once again, you will say, I am saying that generally solid materials are the fixed shape, and generally solid materials are contains the fixed mass and volume, and generally solid materials are contains the intermolecular distance is very short. Intermolecular distance is very short, and at the same time the solid materials are contains the intermolecular force of distance is very short, and at the same time more attractive forces. Generally solid materials are rigid, and I said that here the examples of the pen and examples of the book. So if you drop any material, if you drop any solid material on the floor, what will happen is that molecules are present on the particular position only and particular place only. That's why we are saying that the solid materials are called as the rigid structures. The solid materials are called as the rigid structures. And at the same time, by the observation of these molecules, what I am saying that solid materials are called as the more attractive force. So by the observation of here these example, so salt, NaCl, sodium chloride. In this sodium chloride contains both sodium ion and chlorine ion. Na plus and Cl minus. By the observation of these, the crystal structure of this sodium chloride. So here the attractive forces are very strong. Why? Because here the intermolecular distance of Na plus and Cl minus are very short. Due to that, so they are all contains the more attractive force. Due to that more attractive force, by the breaking of that bond is very difficult. By the breaking of that bond is very difficult. And I am saying that generally solid materials are contains the high melting and boiling points. Generally solid materials are contains the high melting and boiling points, and at the same time solid materials are the good conductors of heat and electricity. The solid materials are contains the solid materials are the good conductors of heat and electricity. So this is called as the information based on the solid materials. And at the same time, you know that examples of the solid materials in our surroundings, so many solid materials are there, like blackboard, chalk piece, duster, and bench, and like that in our TV, in our car, in our bicycle, whatever it. So by the observation of, they are all called as under the examples of the solid materials only. They are all called as under the examples of the solid materials. So thank you.